Hi students, this is the first of 4 videos to walk you through the exam 2 review. This video will cover problems 1 through 5. Problem 1 presents 4 scatter plots. Scatter plot A is a negative association and it's rather strong. Scatter plot B is a positive association and it's kind of weak. C is practically no linear association, and D is a strong positive. So for the strong negative, I am going to pick a negative 0.923. For the moderate positive, I am going to pick 0.736. For the practically no association, I'm going to pick a number close to 0, negative 0.021. And for the strong positive, I'm going to pick a number close to 1, 0.951. Let's check our answer. Problem 2. For many people, breakfast cereal is an important source of fiber. Cereals also contain potassium. An analysis of the amount of fiber in grams and potassium in milligrams in servings of 77 breakfast cereals provided the following regression model. The predicted potassium is 38 plus 26 times the fiber content. If your cereal has 10 grams of fiber, how much potassium does the model suggest? So I'm going to pull up my calculator and let's scoot it off to the side here. So we have 38 plus 26 and times 10. And let's see what we have for an answer here, 298. And we're going to check our answer. That's good. Next problem. Again, it's about the fiber and potassium relationship. From this model, one can estimate the potassium based on the fiber. What does it mean to say a cereal has a negative residual? It means that the potassium content is actually lower than the model would predict given the certain amount of fiber. Let's check our answer. Good. Problem 4. The correlation between fiber and potassium is 0.888. What fraction of the variability in potassium is accounted for by the amount of fiber in the serving? Well, if you square the correlation coefficient, you get the coefficient of determination, and that's the statistic that explains the fraction of variability in the y variable that is accounted for by the x variable. So once again, we're going to take our calculator. We're going to enter 0.888, and I'm going to scoot this over, and we're going to square it. And it's 0.788, and we want it rounded to the nearest tenth, so that would be 0.8. But it's percent, it's in percent, so let me backtrack. That would be 78, that would be 78.9%. 78.9%. We typed that in correctly here, 78.9%. and check our answer. Good. We'll be using StatCrunch for this to get the scatter plot. We're looking at a local newspaper, and they're looking at the age of cars as a predictor for the advertised price. So it would seem as if when the car gets older, the price would go down. So I'm leaning towards scatter plots A and B, and I'm going to click on this icon to get the data. I'm going to click on this icon to open it in StatCrunch. It says I don't have access, but of course I do. So I'm going to close this and try again. Open in StatCrunch. And there it is. So this will happen occasionally, but don't worry about it. We're going to go under Graph, and we're going to pick Scatter Plot. We're using age as a predictor of advertised price, and we're going to get the scatter graph. Okay, so now the deal is we're going to compare this to A and B. A looks pretty good, okay? I can see high value, 2 on the same line, and a dip. 2 on the same line, 2 on the same line, 2 on the same line, 3 on the same line. I'm really hedging towards A. I'm going to close this out, and we're going to pick A. The association between age and price is negative. As one goes up, the other goes down. And it's apparently quite linear. And I would say it's pretty strong. So do you think the linear model is appropriate? So I'm going to check these two that say yes. First one says it's appropriate because the data points from a relatively straight line and there are no outliers. The next says it's appropriate because the data points have been randomized. No, we're going to pick A. R squared is 89.2%. So we need to find the correlation. Well, that's going to be the square root of that number, and we're going to have to attach a negative sign because the correlation is negative. So I'm going to scoot over to my calculator here, and I'm going to enter. So I've got to get that page back again. I'm going to enter 0.892. And I'm going to be taking the square root of 0.892. Confused. So that to 3 decimal places is 0.944. And we're going to make it negative. Negative 0.944. And then we want to explain R squared in this context. It says that 89% that age. The age accounts for the X accounts for 89% of the variation in Y. That would be it. And why is it not 100%? Other factors such as condition and mileage affect the price. Let's check our answers. Good job. Okay, why don't you look at my next video for problems 6 through 10.